Now that we've got a basic idea of what objects are and how they relate to classes, that classes provide sort of the template, the blueprint for what's possible, while objects are specific versions of that thing, just as we know some facts that may be true about people in general, and we know specific people in our lives. I am a specific instance of the person class. Let's take a look at some of those inner workings of a class again. This is the same student class that we've seen before, where we provide the class keyword, the name of the class. We have the initializer, or also sometimes called the constructor, which is this special method inside that allows us to build new instances, new objects of the student type. It also might take some parameters. It always at least has to take the self parameter, and it might take some additional parameters that might be important information about a new student object, like their ID number and the student's name. We may choose to store some of those as variables belonging to the new student object itself. We use the self parameter to reference those sometimes called instance variables. They are variables that belong to this instance of the object. So the ID number 4 that we set up down here when we call the constructor or the initializer gets attached to that new object that's created. And the name Bob gets attached to that new object that's created too. If we create many different students, there will be many different IDs and names. They'll all have the same variable name, but they'll all be attached to a different instance of that class, a different object itself, or in other words, a different version of self. There may be the Bob object and the Sophia object and any number of other objects. Now you might ask yourself for something as simple as this. It's an ID number and it's a name. And yes, we have this display function that we might use. Why wouldn't we just say create a dictionary or 2 lists or things like that of our students? A dictionary for 2 values like this might not be that far-fetched. If we started to grow to where there was a 3rd, such as the list of courses that a person might be taking, or their current GPA, or things like that, then we might be entering into a realm where a dictionary wouldn't make sense, because we'd have to think about what would be the key and what would be the value in those cases between 3 or more different variables. That can get confusing very quickly. So classes and objects allow us to group all that stuff together and not have to determine a hierarchy of what's the key and what are the other things that get clumped together as a value, or that sort of thing. If we think about lists, in this case, we could just have a few different lists, a list of ID numbers and names and GPAs, and at index 0, we know that's all the same student's ID number, name, and GPA. We could do that, but maintaining consistency between those, for instance, if we need to remove a student from a list of thousands of students, we have to remove the ID number and the name and the GPA all at once, or otherwise our different lists become inconsistent. They get shifted out of place with each other. And that can be a little hard to track. So again, classes and objects allow us to group all that data together in a way that's linked, that's tied to each other. And if we let go of that one student, if we just have a list of students, which we can do, when we create a class or objects of that class's type, we can group those together as a list. So we could just have then a list of students, and we know that their ID number, student name, GPA, any other information that's included in the class gets grouped at that index. Wherever the student object is stored, then we can use all of its data by saying student.PID, student.name, or if we have methods, functions attached to the class, we can also call those. And that is the other big bonus of grouping things as classes and of storing objects and having objects on hand, is that we don't just group data, but we can also pair that with behavior, with functions that are specific to that class. Those are called methods. That's just a shorthand way of saying it's a function that was written inside of a class, and that uses this self parameter to be able to use the data of that object. So here, when we call display, we are always calling display with some student object before it, and that gets fed in as the self parameter. And then that way, we are able to ask for the ID of this specific student and the name of this specific student, so that if we had that list of thousands of students, we could grab a student out of that list. We could ask, what is your ID number? We could ask, what is your name? We could tell that student object to display itself as well if it has a display method like the one that's written here. So this keeps all our data clustered together in a way that's consistent and sort of linked to each other, using that self variable, that self parameter inside of the class. And it allows us to attach behavior to it, functions to it. So why do we have to say self? There has to be a way to refer to the current object, the one I have in my hand, the one I have used to call this method, like when we call the display method. It needs to be able to say, who are we displaying? Well, we're displaying whatever object was used to call the display method. A student.display. It needs to know, oh, you mean a student there, or you mean Bob, or whatever the variable's name is, whatever the object's data is. When we're initializing the object, of course, we also need the self there, so that we can set things up for it, so that we can say, your name will be Bob, your ID number will be 4, your list of courses will be this empty list, or whatever. So it is just a parameter, like any other parameter. The difference is that you don't put it inside the parentheses, you put it before the dot to show I am using this object to call this method, and then the method knows that is the self parameter and is able to do things specific to that student or specific to that object. Let's look at another example of a type of class we could write. This class represents a temperature, but the thing about this temperature is we want it to be the value and not to be tied to a specific measurement system. And so, sure, we have to start in some specific measurement system so that we know what the value actually is. And here we're going to use Fahrenheit as our starting point. But the temperature class and any temperature object is able to show itself in whatever of the different formats that we would like it, or the different systems that we would like that measurement to be displayed in. So in the initializer, we have 2 parameters. We have to have self so that we can set things up about this new object that we might be creating. And then we ask for a value. And here the value is going to be stored by default in Fahrenheit. So we take the new object and we tell it, your temperature is whatever Fahrenheit value was passed in as a parameter. We can see how that's used down here because remember the initializer gets called by using the class name. We don't have to type that underscore init to get it to call. We can use the class name, and that makes it clear I'm making a new temperature object. What will that temperature's value be? It will be 32. And we just used the variable name here, Fahrenheit, as 32. That we are giving it the number 32, but the variable name is Fahrenheit, just to make it clear what our input values will be. We could have called this anything we wanted, but for clarity's sake, we're saying users should provide a value in Fahrenheit. We're going to allow you to see that value in whichever of those systems that you want to. So if you want to see it in Celsius, after you've created the temperature object, which we've here called myTemp, we just created a variable and said myTemp will be a new temperature object that is 32. Then we can ask, well, I'd like to get myTemp in Celsius. We say myTemp.getCelsius, and that calls to this method here. The self variable gets filled in by whatever was before the dot. So myTemp, that temperature that was 32 in Fahrenheit. And it does the math to convert this to Celsius and then returns the result of that. Likewise, I can ask for Kelvin. Now, if you happen to remember that Kelvin is Celsius plus 273.15, then you can simply say, get the Celsius value and add 273.15. You'll notice that here we had to say self dot because myTemp doesn't exist in this scope. This is a local scope to the getKelvin method of the temperature class. We don't want to be messing with myTemp. We get handed self. And so when someone asks for the Kelvin value, well, if I want to get the Celsius, I say, whoever my current object is, myself, then I will give you the Celsius, and then you can add 273.15 to that, and you can return it. It's worth noting as well that if I wanted the Fahrenheit value, I don't actually need a method for that because temp is stored by default in Fahrenheit. I could have written a method that just returns self.temp that was called something like getFahrenheit. That would probably be a reasonable thing to do. Here, if I really needed access to the Fahrenheit version, then I could say something like myTemp.temp, because you notice that internally the temp variable is where the Fahrenheit version is stored. So you could just say myTemp.temp, and that would access this instance variable, this variable that was attached to our object. In Python, any of these variables that I create for an object, self.something, they're all going to be by default accessible to things outside of my class if they use the object just like I use self in other places. So I can say myTemp.temp. In the case of my student class, I could have said a student.id or whatever the variable names were there, a student.name. Those are always accessible in Python. In other languages, you can hide them a little more and make them a little more inaccessible to other programmers or to parts of your code that are outside of the class. But in Python, you can just access those variables. You just need the object to be able to reference them, like myTemp dot, and then being able to reference either the variables like temp or the methods. Another reason that we need the self parameter is so that we could do things in relation to other objects or other parameters. For instance, here we've added a method that checks if two students have the same name. We have our self, and then we're being asked, do I myself have the same name as another student? Again, this is a parameter name. It could be anything you wanted to call it. It could be B, or it could be student, or whatever. We've called it another student so that it's clear. There's myself and there's another student. So that if I call something like a student dot same name, a student is self, and then whatever student is provided in the parameters there is another student. It's the other parameter value. So here we're asking, is self.name equal to another student.name? And you can see A student is Bob with an ID number of 4. B student is Tom with an ID of 5. And so this would come back false, right? Self would be a student whose name is Bob. And another student would be B student, which is Tom. And so those names are not equal, and this would come back as false. So this allows us to write methods where I'm checking myself in comparison to some other student, or combining information about myself and another student, or different things like that. So that's another of the uses of self, is you can say, well, what was the object that was used to call this? Oh, that's self. Okay, a student. Great. And then you can have other parameters for other data or other objects, other students. We also can use objects of the types that we've written. So when we define a class and create objects of that class's type, we're defining a new type of data. Just like the types of data that we've worked with, like strings or files or lists or different things like that, we've actually created a new data type in Python. We've done that a few times in these examples that we've seen here. The temperature type and the student type so far. With those types, we can do any of the things that we might be able to do with general data types in Python, like what we can do with strings. Now, we don't have all the same methods unless we write those methods, but things like creating variables that store objects of those types, that reference objects of those types, yes, we absolutely can do that. We can create lists using that type. We can create dictionaries, though we should be careful about what we set up as keys in those dictionaries. You'll get into that at later points when you start to study data structures, but you can use them in dictionaries. You can use them as return values from functions. You can use them as parameters for functions. You can print out information about them the same as you could for any other type. So any of those general behaviors that we're able to do in Python with built-in data types, we can do pretty much all of those with our own new data types that we've defined by defining a class. And one of the most important things that we can do is we can actually use variables of the types we've written inside of another class. And that's what we're going to do here, is we're going to think about, well, okay, students are fine on their own. They're an okay class to have. We can store the ID numbers, the names, maybe we could add a variable for the GPA or stuff like that. But really, there's not a whole ton that we can do with them. But one thing that we could do is we could use them as a part of defining a course object, a course class, a course type. So here I've defined the class course, and we give it an initializer. It needs a department and a number, in addition to the sort of default self that it always needs for an initializer. We say self.department equals whatever department was given in there. Self.number equals whatever number was given in there. So this would be things like CS 128 or things like that. We even can define variables that we don't have a parameter matched to because they might start out empty. For instance, we could keep a roster that's an empty list, or we could keep an enrollment count that always starts at 0, or things like that. So here we've decided that we will create a variable named roster, an instance variable, so it will be attached to the specific classes that we define. Self.roster starts out equal to the empty list. And then we've defined a method for it, enrolling a student. So you need to know the self, what course are you enrolling someone in, and then who the student is. And this is where student objects will come in. We don't want to just store their name. We probably want to store their ID number, their name, maybe their major, their GPA, different things like that. And so we keep that clustered together by using student objects, just like the ones that we were using before. And we say self.roster, append that new student. So that's just taking that roster list that we have and it's adding a new student onto it. And it will actually keep any updates that you do. So that if I call enroll 20 different times to enroll 20 students in CS 128, it will append them, and those changes will persist. So I will end up with 20 students. It won't reset the roster each time. The only way in this class that's defined here to reset the roster is to just create a whole new course. We could also write like an empty out the class or something like that kind of method that would reset the roster too, or drop versus add or that kind of thing. Sure, we could absolutely do that. But what I'm trying to get across is that things like the roster, they continue to exist for as long as the object exists. And changes that we make to them will stick for as long as the object exists and we don't undo those changes. When I enroll a student in the course, even after the function ends, they stay enrolled because the roster doesn't belong to the enroll function. The roster belongs to self. And so as long as this object itself exists, then its roster will stay the way it is. So let's take a look at some of those. We create a course, CS 128. We say it's equal to a new course in which the department is CS and the number is 128. You'll notice that I've stored the numbers as strings here because I'm not really going to do math with course numbers or anything, so it seems fine to store them as the string that holds those numbers. So this will be the course, CS 128. And then I've created Math 180, and its department number, or its department name is Math, its course number is 180. These are two separate objects, but they follow the same course specification. That means that they have a department, a number, and a roster. At this point, both of their rosters are empty, but they are two separate empty lists. Then I create two students, Sophia and Dave, with different ID numbers and different names. We're going to enroll both Dave and Sophia in CS 128. So now the CS 128 roster contains two students, Dave and Sophia. Then we enroll Math 180, or we enroll Dave in Math 180. And so the Math 180 roster is a list containing only one student, just Dave. If we printed out those rosters for CS 128, we would see both Dave and Sophia in the roster. And if we printed out the Math 180 roster, we would see that only Dave was in that roster. So there are many, many more ways that you can use classes to group data, to attach behavior, like methods to that data, to get them to hold on to data across the entire time that that object exists, and to use those objects to build bigger and more complex and more featureful functions, more featureful classes, and more featureful programs overall.